For your living methods, we can look at exercise 16D, question 4. Okay, so we've got a graph with temperature versus time, and we want to estimate the average, not estimate the maximum temperature and when it occurs. So the maximum is right here. The max temp is 25 degrees Celsius, and it occurs when t equals 16 hours. Okay. B, so we've done A. B, we want to estimate the average rate of change between 10 and 4 o'clock. So 10 o'clock is somewhere here. 4 o'clock is not 4 o'clock. 2 o'clock is somewhere here. Okay, so just choose two coordinates. So if that's 10, read it the coordinate. So that's around 7.5. And here it's not 2, but 14 and 22.5. So just find the average rate of change between the two. So y2 minus y1, 22.5 minus 7.5 divided by y2, 22, not 22, 14 minus 10. So work that out, 22.5, so 22.5 minus 7.5 over 14 minus 10. So it's roughly 3.75. 3.75 degrees per second, degrees per hour. Now, this might not be the same as in the book because the book might use a different, well, might read a different value because I'm using my own type to do this, so it might not be as accurate as the book. Okay, estimate the instantaneous rate of change at t equals 20. Okay, so t equals 20 is right over here. Okay, we're trying to estimate what the rate of change is. So you choose a point close to it. You can choose this point. So this will be 2015, and this point will be 2410. And you're just trying to find the normal average rate of change to guess what the instant transfer change is. So y2 minus y1 over x2 minus x1. Okay, so what's on calculator? 15 minus 10. 15 minus 10 divided by 20 minus 24. It's negative 1.25. Negative 1.25 degrees Celsius per hour. Okay. Now again, your guess might be different to the books. The book might choose this as the second point. Okay. So I don't know. I can't guess what the book would choose, but like on the test or SAC, if you choose a reasonable point and you get it right, then that's acceptable. Okay. For question 5, we're given a table of what's happening to a ball when it's being thrown, the height, okay, the distance from the ground. So you're gonna have to draw a graph in your book. You end up getting a parabola basically because the height when you throw something, it goes up in the air, then stops, then it goes back down again. Okay. Use the scale they've given you. When does the ball return to the starting point? Well, it started at 0, and then after 6 seconds, it goes back to 0. So it takes 6 seconds. Find the average velocity between t equals 1 and t equals 2. So you just try to find the average rate of change between these two. All you need to do is go y2 minus y1 over x2 minus x1. It's distance over time. Velocity is distance over time. So 2 minus 1. That's 15 over 1, which is 15 meters per second. Okay. Find the average velocity between 1 and 1.5. Uh-oh, we got a problem. We don't know what 1.5 is. Okay, but we've got a table. I can use the regression tool on the CAS. So you go to spreadsheet. I've typed in the numbers. You can go calc regression, quadratic regression, get the equation. Oops. Need to remember to highlight regression, quadratic regression. So negative 5x squared plus bx. Okay. So let's double check I got the right values. 0, 1, 2, 3, 4, 5, 6. Yep. 0, 25, 40, 45, 40. Yep, that's good. Okay. So negative 5. So D. Oops. d equals -5t squared plus 30t. Okay, so you're going to calculate what 1.5 is because we need to work that out. So -35 times 1.5 squared plus 30 by 1.5. So -33.75. Okay. There's a almost a value here. Let me check what the issue is. Something not quite right about this. No, that should be okay. So, okay, -5. Okay, so it's 33.75. Okay, so at t equals 1.5, we get 33.75. And at 1, we get t equals 25 because it's right here. Okay, so average rate of change 33.75 minus 25, y2 minus y1 over x2 minus x1. So we should get a value of, let's work this out. So 33.75 minus 25 over 1.5, 17.5. Okay, so that's 17.5 meters per second. So that's done. Estimate estimate the velocity when the ball t equals 1. So I won't go through every single one. For t equals 1, what you do is you could use these 2 points, okay, to estimate that. Okay, so you're getting a point close by. So 0 is a point close by. What's the average velocity? You use those 2 points. Okay. For t equals 4, you might want to use these 2 points. Okay. For t equals 5, you might want to use these 2 points. Okay. So again, your answer might be slightly different than books. Okay, because for t equals 5, they might use these 2 points instead of these 2 points. Okay. So I'll let you do those ones yourself. Now, question 6: a stone is thrown upwards from a from the edge of a platform just 10 meters above the ground, which makes sense because it's starts up at 10 meters away from the ground. From the graph, estimate the instantaneous velocity at which the stone is thrown. Okay, so you can choose. You just need to choose. You're interested in the instantaneous velocity here, so you can choose a second point that's close by. You might want to choose the maximum. Okay, so I'm not going to go over with you. Just use this point and use that point. Find the gradient of those 2 points. Okay. What's the maximum height the snow reaches? 15 meters. At what time does the snow reach maximum height? 1 second. At what time does the snow hit the ground? Well, it's roughly, I think it's 2.6, maybe 2.8 seconds. Okay. Again, it's really rough because you don't know exactly what it is. From the graph, estimate is strange when estimate change when the stone hits the ground. Okay, from the graph, estimate is the instantaneous speed at which the stone hits the ground. Okay. A stone is thrown vertically upwards from the edge of the platform, which is 10 meters above the ground. Okay. Now, this is a bit of a tricky question because you sort of extend this a bit more. Why do I extend this? Because 10 meters. Actually, no, you don't. It's not tricky at all. It's just we're just trying to find instantaneous rate of change at that point. So the instantaneous rate of change at that point is, well, you're interested in the grade at that point. You can choose a second point like here to roughly read like what the and find the instantaneous no find the average rate of change between these 2 points. to get your answer. So again, it's not going to be accurate. It's going to be slightly off. Okay, so what the book's going to have. So hopefully that helps. Question 7. I'll just briefly talk about it. At what times is the particle at zero? Um, well, it's at zero when it's zero away from uh, the starting point, not starting point, but zero away from the reference point. So it's zero when x equals 2 and 3 and 8. Okay. What values is the particles moving to the right? Um, so it's basically asking you when is the gradient positive. It's gradient positive there, up to here, and then it's positive there. So I'd say between 0 to wherever the maximum is, 2.5, not including 2.5, and then when it's 6, not including 6, to infinity. Okay, not including infinity. So it's between these times. For what values is the uh, particle stationary? Okay, stationary means if it goes, if it has to change direction, then it has to, there must be a stationary point there. So it's stationary here and stationary there. So at 2.5 seconds and 6 seconds. So hopefully, I haven't gone over like each question blow by blow, but hopefully I've explained enough for you to get started.